Hi, I'm Megan Cohen. I work in Dr. Katner's lab studying hepatocellular carcinoma. This is a liver cancer, so it's a solid tumor in the liver. It causes about 1 million deaths annually. It's been exceedingly resistant to chemotherapy, so I want to look at ways of treating this. So hepatocellular carcinoma, and we're going to zoom in on the cancer cell in the liver. So I'm focused on notum, which I think comes in and cleaves off glypican-3. Now, why do I care about this glypican-3? Why do I care if it gets cut off? I'm going to talk about that here. So when glypican-3 is attached to these HCC cells, I'm able to target it through therapy. So there's new therapies on the market that can target this glypican-3. Ultimately, if it's cut off from the surface, it's not going to work. It's not attached to the cell anymore. So I want to find a way to stop that cutting so I can treat this cancer. So last year, I looked at the relationship between notum and glypican-3. So what I did is I added extra amounts of notum, and what I found was that glypican-3 did increase. Like there was more of it cut off from the surface, which is good because it's saying that, hey, notum does play a role in this. Then what I did is I knocked out notum. So what is a knockout? So in a regular notum in the cell, it has this long code and it makes this functional protein. So the cell reads this. What I did is I altered it so it's shorter, and I made a non-functional protein, so there would only be a chunk of it, so it's not going to be able to cleave off glypican-3. So this year, now that I have this knockout, I'm going to run ELISAs on the knockout cells by adding varying amounts of notum and seeing, now that I can completely control those levels, how much glypican-3 shedding I'm getting. And then I'm also going to do bioinformatics that focuses on other factors that could be involved in it. Ultimately, my goal is to find a better treatment for this cancer.